Alright, this is going to be our last video on this unit, and we're going to talk about the fundamental forces in nature. There are only 4, and we've already talked about 2 of them. We're just kind of bringing them all together. So, fundamental forces. Number 1 is gravity. Okay, we have done gravity. We have talked all about the gravitational force. Our formula for that is gmm over r squared. And what gravity tells us is the force between masses. We've been calculating with that. We will continue to do calculations with that. But that's all there is. The next one we have is the electromagnetic force. We've been looking at specifically the electric part of that force. We will talk about magnetism later. It's KQQ over R. That specifically tells us about the force between 2 charges. And what we're going to say about this is that electricity and magnetism are completely different phenomena, but their underlying physics is very, very close to, well, it is the same thing. So they're explained by the same thing, but they are 2 completely different phenomena. So I don't want you to think that anything that we're doing in class has to do with magnets yet. Magnets are a whole separate thing. They have north and south. We're talking about plus and minus. But they are a similar force, so when you're tempted to say, oh, it's like magnetism, yes. But it's not being caused by the same thing magnetism is caused by. But they have the same underlying physics behind them. And so they're sort of unified together under one force. And again, these are the 2 that we're going to have to calculate with. And again, this tells us the force between charges. Plus and minus charges. Okay, next one, and you talked about this last year in chemistry, is the strong nuclear force. We're not going to do any calculations with the strong nuclear force, so don't worry about that. The strong nuclear force is inside of the nucleus, and it's what holds the nucleus together. It keeps protons stuck to other protons. And we call this the strong force because protons are both positive, are all positive, and they are repulsed by each other. So inside of the nucleus, the strong nuclear force needs to be strong enough to overcome that electric force. Okay, so protons are repulsed by each other. The strong nuclear force has to be so strong as to overcome that repulsion. And that's all we're saying here. Protons are repulsive due to the electric force. In order to create a nucleus, the strong force must overcome the electric force. So if we look at, I guess, a lithium nucleus, we have this electric force that is pulling the nucleus apart. But there's this other force, the strong force, that forces these things together. Okay. If the nucleus is too big or there are too many protons in one place, alright, if the nucleus is too big or we have too many protons present, we can overcome the strong force. It breaks down, basically. So if the nucleus is too big and there's too much electrical force, the strong force will break down. This is fission. This is nuclear fission. When we have a nucleus that splits, it is because of a breakdown in the strong nuclear force. And now we have our last fundamental force. This one's called the weak nuclear force. All right, the weak nuclear force holds the little things that make up the little pieces of a proton. We call those quarks. It holds them together to make a proton a proton. So, weak nuclear force holds the pieces of a proton together. A breakdown in the weak nuclear force causes what we call beta decay. In this, a proton will randomly kick out an electron and turn into a neutron. These are our okay. A proton ejects an electron and becomes a neutron. These are our four fundamental forces. Every force that you could possibly think of is due to one of these four fundamental forces. The strong nuclear force and the weak nuclear force are confined inside of the nucleus. So really everything that you encounter in everyday life is gravity and the electromagnetic force. One thing that all of these have in common, all fundamental forces, are non-contact forces. They act at a distance. That's the similarity between all of them. Okay, this is all we have.